So the five main types of reactions are synthesis, decomposition, combustion, single replacement, and double replacement. Now, sometimes a reaction might occur in more than one step, so it might be a combination. So maybe a double replacement would happen and then a decomposition or something like that. But these five main types are what we're going to concentrate on. And as you're writing and balancing equations, you need to identify what type it is. Okay, if it's a combination of those, I wouldn't expect you to get that. But you need to be able to get the five main types. So we're going to go through each type. So the first type is synthesis or combination. This one is easy to recognize because you just get a single product. So as you are looking over the reactions, anytime you're getting one product only, that's synthesis or combination. It might be two elements reacting together to give a single product. It might be a compound with another element adding on to get a single product. It won't normally be two compounds combining together to give a single product. It's usually either a compound and another element or two elements combining to give one product. But that's synthesis or combination. Combustion is when you have something burning, okay? Burning, not just heating, burning. It has to actually light on fire. So the most common types of combustion are hydrocarbons, methane, propane, gasoline, kerosene, any of those burning in oxygen. So often in combustion, very often, one of the reactants will be oxygen. And then if it's a hydrocarbon burning, the carbon combines with the oxygen to make CO2. The hydrogen from the hydrocarbon combines with the oxygen to make water. And then also in combustion, you get energy released, either in the form of heat or light or both. So the whole reason we burn these hydrocarbons is to produce energy, whether it's in our house, in our grill, propane, in our car, gasoline. Okay, so we're getting a hydrocarbon with oxygen to give CO2, water, and energy. Okay, so those in the description, it should say that the substance is being burned. Okay, not just heated. And the substance should, so in lab, when we physically light a piece of magnesium on fire, or we do something with actually burning it, not just heating it, okay, that's combustion. Decomposition is the opposite of combination synthesis. In those, we had things making one product. In decomposition, we have one reactant breaking apart. So it could be a compound breaking into elements, or it could be a compound breaking into simpler things like here we have KClO3 breaking into a simpler compound, KCl, and then O2 is given off. Okay, so a element will not be able to break down into something else. It's going to be a compound, but you'll have one reactant breaking apart. That's decomposition. The next type is called single replacement. Single replacement is when you have one element by itself. It might be one of the Hofbrinkel ones, so it could be like Br2, Cl2, whatever, but it's a single element with a compound, and the element has the ability to replace something that's like it. So a metal can replace another metal. A metal is not going to replace just some random non-metal, but a metal can also replace hydrogen because hydrogen only has one electron and it's like a metal. So a metal can replace a metal can replace hydrogen, and we're going to go more into single replacements in a minute. Okay, so down here on my examples, lithium's replacing sodium, taking the chlorine, and then the sodium gets kicked out. Or in the second one, lithium can replace hydrogen, So the lithium is kicking out that hydrogen and taking the OH. When the hydrogen gets kicked out, it has to become H2 because of Hofbrinkel. So we can't forget about those 7 that I told you about before, Hofbrinkel, that those are always diatomic when they get kicked out. Okay, so there's H2, not just H. So the Li is replacing hydrogen. So think of water as HOH, not H2O. Li replaces H, combines with the OH, and that's another single replacement. Right? Whereas double replacement is when you have 2 compounds that are switching partners. And in this case, it's 2 ionic compounds, so the cations are switching. So if we had like 2 couples at a dance, then we would have, in this case, a boy and a girl and a boy and a girl, because like can only replace like. So if we have 2 couples with a boy and a girl, and then the boys switch places so that we get the one boy with a different girl and the other boy with the other girl. Because like can only replace like. So we couldn't have the boy going with the boy in this case because it has to be like going with like, not like replacing like, not like going with like. So all of these will have a plus ion with a minus ion, a plus ion with a minus ion. So the 2 pluses can switch places. The 2 pluses are not going to get together. Right? So double replacement, you have 2 compounds and then the cations switch places. Okay, so with that, we had been looking at the problems from the paper where we were writing a balanced equation. Then we had to identify what type they were. So with this, sorry, I'm trying to make it bigger. And I don't know that I'm going to be able to make it bigger, but hopefully you can see it. Plus, I posted this separately. So with this first reaction, where we had iron chloride breaking down, that would be decomposition. In this one, we have copper 2 nitrate with potassium, and then the potassium is replacing the copper. So that's single replacement. We had an element by itself with a compound. The element replaced, the metal replaced the one metal. In the next one, we had a single replacement again because we had fluorine by itself, and we had a compound, NaCl, and the fluorine was able to replace the Cl and kick out the chlorine. Like replaces like. This is a halogen replacing a halogen, single replacement. Number 4, we have 2 things combining together. We only get 1 product, so that's combination or synthesis. In number 5, we have a metal replacing hydrogen in water to produce hydrogen gas, and then the metal went with the OH. So that 1 H was kicked out, it had to then gain a partner to be Hofbrinkel, and then the Na went with the OH. So that was also single replacement. Number 6, it says propane gas is burned in oxygen, CO2 and water are formed, that's combustion. And then the last one, we have another single replacement. Aluminum is replacing the hydrogen in the acid and kicking out hydrogen, and then hydrogen becomes H2. So that is also single replacement. Okay, so that was the assignment from yesterday. Then just going a little bit more into single replacement reactions is what I was doing today. And with single replacement reactions, I need to pull up, I had a PowerPoint with this on it. So again, and I posted this PowerPoint for you, but same thing, combination or synthesis with the first one, then decomposition, then combustion. Those are all the same. And then we get to single replacement. So with single replacement, there are 3 different types. Always, it's a more reactive element replacing a less reactive element. So in the first type, metal can replace metal if the metal is more reactive. So I have a separate paper that we'll look at in a second that is called the activity series. And I've put a copy also on here. And the way they're listed, the more reactive the metal is, the higher it is on the chart. The less reactive, the lower it is on the chart. So the activity series you use with a metal replacing a metal to see if it can happen. So for instance, Li is higher on that chart, on that activity series, than sodium. So Li can kick sodium out and take the chlorine. Okay, so that's metal replacing metal. Halogen replacing halogen, you can just look at the periodic table. The higher it is on the periodic table in that group, the more reactive it is. So a fluorine can replace chlorine, bromine, or iodine. We don't really talk about the lower two. But chlorine cannot replace fluorine because chlorine is lower on the periodic table than fluorine. But chlorine could replace bromine or iodine. Okay, so higher halogen can replace lower halogen, not vice versa. So here we have chlorine, and it's a Hofbrinkel, so it has to be Cl2. So chlorine can replace bromine in that potassium bromide, and then we get potassium chloride. The bromine gets kicked out, it picks up a partner, bromine, so that it's Br2 because of Hofbrinkel. So a halogen can replace a halogen. And some metals can replace hydrogen if the metal is reactive enough. So this is also on the activity series that we're going to look at here in a second, that if a metal is reactive enough, it can replace hydrogen from acid. And if it's really reactive, it can replace hydrogen from water. So like this, zinc can kick out the hydrogen and steal the chlorine from HCl. That hydrogen that gets kicked out, though, has to become H2 because of Hofbrinkel. And then the chlorine gets together with the zinc, and you balance the charges. Zinc is always +2, so the chlorine, you would need 2 of them. Okay, so metal replacing hydrogen. Okay, so I'm going to show you the activity series paper, which is right here. Okay, and so this, again, you can print this out. If you look at the little chart, lithium is the highest on there. So lithium could replace any of the other metals. Potassium could replace all the other metals but lithium. And then barium is very reactive, calcium is very reactive, sodium is very reactive. So you check the chart. If it's higher on the chart, it can replace lower. And then just side note, alkali metals and alkaline earth metals can always replace transition metals. So alkali and alkaline earth are the most reactive, and they can replace any transition metal. Otherwise, you can look on the chart because it's a little confusing with, we always say that alkali metals are the most reactive, yet barium and calcium are higher for a single replacement reaction than sodium. So barium can replace sodium, calcium can replace sodium. Okay. Then there's 3 black arrows on this chart that correspond to the different hydrogen possibilities. Sorry, this went blue. Oh, now it left. Sorry. Little come back. So with this, the little tiny arrow just shows the top 5. So the top 5 metals listed on here, lithium, potassium, barium, calcium, and sodium, those are reactive enough to replace hydrogen from water. So I showed you the demo. We threw sodium in water. Sodium can react with just water. Then the second arrow that's a little bit longer shows that all the way down to iron, those can replace hydrogen from steam. So with the extra energy that steam has, it's still water, but it has more energy. More of the metals can replace hydrogen from steam. And then all the way down to lead, all those metals can react with acid. So they can replace replace hydrogen in acid, okay, to kick out the hydrogen as H2 gas. So in class, we're doing a demo with magnesium, or actually we used zinc to take zinc in acid and make hydrogen gas. We fill a balloon with hydrogen gas and then light it to show the little explosion of hydrogen gas. Okay, but you have to use this activity series, the top part of this paper, for single replacement. The bottom part, the solubility rules, that's with double replacement that we won't get to till next week or later. Okay, so single replacement reactions with a metal replacing a metal or a metal replacing hydrogen, use that chart.